Good morning, all. Look at this rather imposing looking integral. How do we go about finding the antiderivative of a function like that? Okay, rather intimidating. A clever trick though, let me show you how we do it. It's called a trigonometric substitution. Usually when we make a substitution, we start by saying let u equal something involving x. Here we start off by taking this dummy variable and we let x equal the sine of u. Another way of writing it would be u would be the arcsine of x. So we really could write it in terms of u. U is equal to the arcsine of x. But this is the way we use it. And so that's the easiest way to write it down. So how is that going to help us out? Let me show you and you'll catch on. So as always, we need to find out what dx is. So dx is equal to cosine of u du, right? Take the derivative this side and slap on your du. Now, as always, we make our substitution. We have to turn all of this thing into u rather than into x's. And really, that's all there is to it. The rest of it just kind of follows. So let me show you, and let's see once what happens. So this is going to be 1 minus x squared, which is 1 minus sine squared. Okay, I'm going to do several steps in one, might as well. 1 minus sine squared is cosine squared, agreed? Because we're using the fact that sine squared anything, I'll say x, or u rather, I'll use, u plus cosine squared u is equal to 1. So 1 minus sine squared is equal to cosine squared. So let me say it again. This is going to be 1 minus sine squared, which is cosine squared. Once you have cosine squared, notice that you take the square root of it. That's what the 1/2 is, so that gives you cosine. And now you're going to get cosine to the 5th power. So all of this down here just ends up being cosine to the 5th power of u by the time you're done. Okay, now we have to get this in terms of u as well. X cubed is going to be sine cubed of u. And finally, dx is going to be cosine of u du. So this is cosine of u du. And now notice we've just turned it into the kind of integral that we were doing in the last lesson, right? Now how do you finish it? This cancels with one of these, and we'll be left with a 4. Agreed? I've got an odd number of signs, so now I'm going to write this as sine of u off to the side du, and then I have a sine squared left. Sine squared is 1 minus cosine squared u, and then here I have cosine to the 4th. So now I need to make another substitution. Let's let t be equal to the cosine of u, and so dt is equal to minus sine of u du. See that? So this becomes 1 minus t squared over t to the 4th, and then sine of u du is a negative dt. So you have that. Or you know what? Instead of making it a negative dt, I just don't like negatives. I'm going to just apply that negative to this and make it a t squared minus 1. The fewer negatives you have in your life, the better. Okay? So there you go. And now it becomes just an algebra problem. This thing you can write as t squared over t to the 4th. T squared over t to the 4th is 1 over t squared. 1 over t squared you can write as t to the negative 2. And then you have minus, this is going to be t to the negative 4th. Okay? I'm going to have to do several steps in one here because I have limited amount of space. So that's okay. You should be at the point now in your algebraic skills that you can handle that. So now what's the antiderivative? Now finally we can take the antiderivative. you what? You add 1 and divide by it. So it's going to be t to the negative 1 divided by negative 1 minus t to the negative 3 divided by negative 3. So it's going to be that plus c. Now you just start substituting in backwards again. So this is going to be 1 over t plus negative 1 over t rather, plus 1 over 3t cubed plus c. And t is equal to cosine u. So this is equal to negative 1 over cosine of u plus 1 over 3 cosine cubed of u plus c. Okay, are you with me? And now, finally, we need to get back in terms of x. So notice that since this is true, that means that u is equal to the arcsine of x. So this is equal to negative 1 over the cosine of the arcsine of x plus 1 over 3 times the cosine cubed, cosine cubed of the arcsine of x plus c. Okay? So now we have it all in terms of x, which is what we wanted. Okay? We've got a function right there, and we wanted to know what's its antiderivative. What's the function whose derivative is that? And there's our answer. However, if you look at it, this answer, first of all, doesn't look very much like that at all. It would seem that if you wanted to take some function and take the derivative and end up with that, you would start off with something that looked at least a little bit like that. This certainly doesn't. Secondly, whereas this thing at least is something that if I gave it to you in the Calc 1 class and said graph it, you'd be able to find out what the vertical asymptotes are and what the horizontal asymptote is, and you could go through the derivatives and find out where it's increasing or decreasing. This function here, wow, it's going to be a couple levels of difficulty more, because you're starting off with something that you just have no intuitive sense at all of what this thing is. So the point is, I'm trying to lead you into thinking, let's get this into a better answer than this. So I'm going to have to do some erasing in order to do it. So this is something that I teach in pre-calculus, and I think I taught it early on in the Essentials of Calculus class on YouTube as well. Let me show you how to do it. We want to write this in a better form than this. So what do? I make myself a triangle, right triangle, and I say I want the angle whose sine is x. So here's my angle right there. I want an angle, that's what this stands for. It's the angle whose sine is x. What's the easiest way to make an angle whose sine is x? The easiest way is to make this x right here and make that 1 right there. There's an angle whose sine is x. Now that I have that angle, I want the cosine of that angle. What is the cosine of this angle? Cosine is this over this. Well, I need this length. How do I find this length? I can use Pythagorean's theorem, and I'm going to skip the details here. Well, I call it L, and I can say that L squared plus x squared is equal to 1, and solve it for L, and you're going to get L is equal to the square root of 1 minus x squared. So there is the cosine of the angle whose sine is x, and so now I can finally write my full answer. If I have space for it, it's going to be minus 1 over the cosine. So the cosine is this over this, so it's going to be the square root of 1 minus x squared. You see that? Yep. Plus 1 over 3 times the cosine is this over this, and notice I want to cube it. So it's going to become 1 minus x squared to the 3/2 power. There you go. Plus c. If you take this and cube it, you're going to get it to the 3/2 power. So there's your final answer. if you have the guts for it, go ahead and take the derivative of this whole thing. It's going to take a little bit to do it. Take the derivative of this whole thing, do all the simplification, and by the time you end up, you should end up with that. Okay, so there you go. So that's the way this works. It's called a trig substitution. Okay, so having done that one, let me make things just a little bit messier, as if that's not messy enough. Okay. I'm going to use the very same problem. I'm just going to make it, as I say, a little messier. Let's make this a 25 right here, and make this a 9 right there. Okay? So the point is, we don't have to have all ones there. We can have a number there and there. And I made them squares just to make the numbers even a little nicer. But they wouldn't have to be. This could be a 7 and this could be a 3 for that matter. Okay. The point is, we want the same sort of thing to happen. What was the whole point here? The point was to get this messy looking thing just to be, in this case, a nice cosine. See that? That's what we're after. So how can we make, what choices do we have here so that this thing here just turns out into a nice cosine? And here's what you do. You take the square root of this number. Instead of an x, it's going to be 3x. So it's going to be let 3x equal, and then you take the square root of this number, which would be 5, equal 5 sine of x. Let 3x equal 5 sine of x. After that, everything is just the same. Let's just see. So 3dx is going to be 5 cosine of u du. Let's see I'll go ahead and erase this and just show you that we won't finish the whole thing because it's the same problem. It's just going to have a few constants going around. But watch what happens. So this thing, what happens to it? First of all, x cubed. What's x cubed going to be? Well, if you solve this, well, let's first do this. You're going to get 25 minus 3x squared. Okay, this is what's key. No, 9x squared, I mean. Notice that 9x squared is the square of this thing. See that? 9x squared is the square of this. So instead of putting this thing squared in, I'm going to put this thing squared in, and I'm going to write it then as 25 minus, if I square this thing, I'm going to get 25 sine squared of x all to the 5/2 power. See that? Let me do it again. Here's 25, that's right there. 9x squared, that's the square of this. So instead of putting in the square of this, since these are equal, I'm going to put in the square of this. The square of this is 25 sine squared of x, all to the 5/2 power. Now, what's x cubed? If I solve this for x, I'm going to get 5/3, this thing cubed. The 5/3 I'm going to bring out front. So here's the 5/3 quantity cubed. It's brought out front because it's x cubed. So it's going to be 5/3 quantity cubed, and I'm going to be left with the sine of u quantity cubed. And then what's dx going to be? Notice that dx is going to be what? 5/3 cosine u du. So here's your cosine of u du. The 5/3 is going to come out front again, so this 5/3 to the third becomes 5/3 to the fourth. Okay, it's not hard, it's just numbers. If you just know how to multiply numbers, don't let it scare you. Okay, all you're doing is just having some numbers attached, but integrals don't care about numbers at all. Now notice it's the same thing as before. Now I'm going to get 5/3 all to the 4th power, and I'm going to get sine cubed of u cosine of u. Okay, now here's what's key again. Look at here. this 25, this is why I chose this exactly as I did, because this number and this number is the same. See that? I started off with this number being different from this number. That made it tough. Now that they're the same, notice what I can do. Again, I'm going to do a bunch of algebra here, okay? This is algebra. I'm going to factor the 25 out from both of these. So I have a 25 here. Then I'm going to bring it outside of the parentheses. When I bring it outside, I have to first take it to the square root power. That's square root of 25 is 5, and then it's going to become 5 to the 5th. So when it comes out, it's going to become a 5 to the 5th out there. See that? So now I've gotten rid of all those constants, and now I have just what I had before. I have a 1 there and a 1 there. So what do I have? 1 minus sine squared is cosine squared. This makes it cosine. This makes it cosine to the 5th. And now it's the exact same problem we had before, right? So this goes with this, and you do it exactly the same way as before, and you're just going to have the same sort of answer, but with constants out front. Okay? When you get to your final answer, which, doggone it, I had no choice. I had to erase something here. You're going to make yourself a triangle which follows the same as before. So I'll do one other one like that just to see how it all works. Okay? So that's the way it works. Okay? So that all works really slick. Whenever you have something of the form, say 25, some constant minus something times an x squared all to a like a square root, or it could be a square root, or 3 halves, or 5 halves, or whatever. Could be in the denominator, could be in the numerator, doesn't matter. When you see things like this, that's when you end up using a trig substitution. Okay, let's try another one. Okay, let's try this one. Okay. Okay. The thing to notice about this one is that it's very different from the previous one. If I had a minus there, then I'd be able to say, let 2x be equal to 3 sine of u. And if I had a minus there, let me just put it in there real quick. Then for this thing squared, I'd be able to put in a 9 sine squared of u, and I'd be able to factor the 9 out, and I'm left with 1 minus sine squared. 1 minus sine squared is cosine squared. You take the square root and you get the cosine. No problem. That's very nice, as long as you have a minus there. With a plus there, it's not going to work at all, right? Because with a plus there, you're going to end up with something like this. 1 plus sine squared of u. Totally worthless. That's not going to help you. We don't have any identity that tells us what 1 plus the sine squared of u is. So with a plus there, this substitution is not going to work. What can we do? What can we do? Are we stuck? No, obviously not. Otherwise, I wouldn't have put it up there. Okay, but here's what you can remember. You can remember that since sine squared u plus cosine squared u is equal to 1, that if you divide everything through by cosine squared, you're going to end up with what? you're going to get tangent squared u plus 1 is equal to secant squared u. Ah, there's the kind of thing we're looking for. See that? We've got a plus in there. There's a plus. There's a plus. Maybe we can make use of this. Let's give it a try. So here's what we do. Watch how it's going to work. Okay, this is the identity we're making use of. And so I'm going to say let 2x, you take the square root of this thing, equal the square root of this thing, 3 tangent u. Tangent u. Okay, let me make sure that my computer is still working here. Okay, very good. Every once in a while, this program that I'm using stops, and I have to start it up again and splice a couple things together. Okay, very good. That's all you really need to know. The rest of it is mechanical. Okay, let's see once what happens. Okay, let's see once what happens. So, what happens here? First of all, I'm gonna replace this with 9 plus 4x squared is the square of this thing. Instead of putting this thing in there, I'm going to put this in. Okay, so plus 9. If I square this thing, I'm going to get 9 tangent squared of u. There it is. That's what I want. See that? Because by the time I factor the 9 out, I'm going to be left with a tangent squared u plus 1, which is exactly what I want. I got a nice trig identity for that. The rest of it is all very mechanical. Let's go through the mechanics. I've got an x squared there. What is x squared? Well, let's see. X is equal to 3/2 tangent u, right? So x squared is going to be a 9/4. So that's going to be down here. I'm just going to bring it down here. 9/4. Okay? And this is the tangent squared right here. Tangent squared u. Okay, so that takes care of that. What do I have upstairs? I have a dx. I need to get a dx. What is a dx? Well, let's figure it out. Dx is equal to 3/2. What's the derivative of the tangent? It's the secant squared of u du. So up here, I'm going to have a 3/2, and then I'm going to get a secant squared u du, like that. Okay? There it is. So now the rest of it again is mechanical. So let's do the first step. The first step, first of all, I can bring this up as a 4/9, and so I'm going to have a 4/9 times 3/2. If I take 4/9 times 3/2, these things cancel, and I'm going to end up with 2/3. So it's going to be 2/3. Okay. Now, let's see. I can also bring the 9 out of here. When the 9 factors out, it comes out as a 3. It can come all the way out, and I'm going to end up with a 9 right there. Because I brought this 9 out, it comes out as a 3, and I multiply it by that 3, and I'm going to get a 9. That takes care of that. So now these things become just 1. Okay? Now I have what? I have secant squared u, and then down here I have a tangent squared u, and then 1 plus tangent squared. That's the whole point of doing this. 1 plus tangent squared is equal to secant squared. The square root of secant squared is just secant. It's just secant right there. See that? So, of course, one of these cancels with one of these. So I end up with a secant upstairs and a tangent squared downstairs. Now, as I told you in our last lesson, whenever I see things to odd powers, I like to put it in terms of sines and cosines. That's usually the best bet. No guarantee. That's the whole point. That's the fun part of doing antiderivatives. is you never have any guarantee. You just got to give things a try. So let's go ahead and do it. So first of all, secant is 1 over cosine. So I'm going to get a 1 over cosine u there. Tangent squared is sine squared over cosine squared, right? So the sine squared stays down here. Here's your sine squared divided by cosine squared. So divided by the cosine squared, that's going to flip up on top. So you have that right there. Du. And now notice that one of these cancels with this, and I just end up with 2/9 times what? Sine squared on the bottom and a cosine u du up on top. See that? Now I can let t be equal to sine of u. And what do I get? I'm going to get, let's make a big old, is equal to what? 2/9. And it's going to be t squared, 1 over t squared. So t squared down there. Cosine of u du. Again, I'm going to just stop writing some of this stuff down because you should understand it by now. Here's your t squared. Now you have, I have to have a dt. Doggone it, I guess I don't know where to fit it in. dt is equal to cosine of u du. Okay? So all this stuff on top becomes your dt. Right there. So it's going to be 2/9 times the antiderivative of t to the negative 2 dt. Take the antiderivative, you're going to get 2/9. It's going to be what? T to the negative 1 divided by negative 1 plus c, which is going to be 2 over a negative 2 over 9t. Negative 2 over 9t plus c. Okay, there it is. Now you need to put it back in terms of x's again. So what do? The first thing you do is to write it as sine of u. So it's going to be negative 2 over 9 sine of u plus c. Okay. Equals negative 2 over 9 sine of, what is u? Well, how do we find u? We first bring this over and we get, I'm just going to have to erase this, okay, no choice. Hate doing that. But what does this mean? This means that tangent of u is equal to 2x over 3, and so u is equal to the arctangent of 2x over 3. Okay? So this is equal to negative 2 over 9 sine of, here's your u, arctan of 2x over 3 plus c. Okay? Same thing as before. Very untenable, right? What in the world does this thing look like? What is it? It doesn't look anything like this. Let's try to get it into an answer that is just makes easier to work with. So what do? I draw myself a triangle. Here's this angle. It's the arctangent of 2x over 3. What's the easiest way in the world to make an angle whose tangent is 2x over 3? I want an angle whose tangent is 2x over 3. Heck, make this 2x and make that 3. Agreed? That's what the tangent is. It's opposite over adjacent. So there's an angle whose tangent is 2x over 3. Now notice I need the sine of that. The sine is this over this. How do I find this thing? Pythagorean's theorem. What does Pythagorean's theorem say? It's the square root of this thing squared, which is going to be, well, let me do it this way. It's this thing squared, which is 9, plus this thing squared, which is going to be a 4x squared. Ah, look at there. I ended up with something very similar to what I started with. That's encouraging. If I didn't, something would have been amiss. Okay, so where are we now? We're at -2 over 9. Now we want the sine of this angle. What's the sine? The sine is this over this. So the sine is 2x over the square root of 9 plus 4x squared. And we'll throw our c on the end. That's good. And then finally, notice what we can do. This 2 cancels with this 2. This thing comes up on top, and I end up with the square root of 9 plus 4x squared all over. I still have a 9 on the bottom, and I still have an x on the bottom. See that? All over 9x, and I have a negative right there, plus c. There you go. So that's how it works. So you make a tangent substitution when you have a plus there, and you use a sine substitution when you have a negative there. You could also have used a cosine, but everyone always just seems to use a sine, and there's no reason to use one over the other. So just make it standardized and let it be sine for that first one we did. Okay. So there you go. Okay, that's the way it works. The only other kind you could get would be what happens if you have something like this, 4x squared minus 9. Notice you have a minus there again, but this time you have the x squared in front. That would be similar to saying something like sine squared x minus 1. That doesn't work because you'd get a negative cosine in there, which is no good. You get square root, so that's no good. And so this is one where you would actually use a secant substitution. You let x be equal to secant of u. I typically I just don't do those. I figure if students understand these two, they kind of understand the method. And then if they want to run into something like this, they can go to a table book or whatever and get the answer. But textbooks often do this one as well. You have to kind of make choices in what you present and what you leave. So anyway, there's that one. Okay, let's do one more just to show you. Just to show you how you would use this for a definite integral as well. Okay, so suppose we have this. Suppose we have okay. Let's do this one. Okay, well, let's see. First of all, you notice you have a minus there, so I'm going to say let x be equal to 3 sine of u. So dx is equal to 3 cosine of u du. Okay, agreed? So watch what happens. We're going to get 9 minus x squared is going to become 9 sine squared. So dx is going to be 3 cosine of u du. And we're going to have to change our limits of integration. See this? So one option would be to do them like we did it before. Just get rid of these limits and do the whole thing as we did before. Get it all back in terms of x. Once you get it all back in terms of x, like we did in the previous two problems, then you go back and you stick in your limits. That's totally fine. I typically like to just change the limits as I go. Some of these, I don't know, it's just my preference from doing them over the years. So let's go ahead and do it this way. So let's see what happens. When the dummy variable here is 0, when x is equal to 0, what does u have to be? So in other words, I'm saying if x is 0, the sine of what is equal to 0? Oh, the sine of 0 is equal to 0. Okay, that's good. What happens when x is equal to 3? Well, if x is equal to 3, that means that the sine of u would have to be 1. When is the sine of u 1? That's at pi over 2. See that? So the advantage of this, I never have to go back to this problem now. It's equal to this, and so I can just do this one. Okay? Now, let's do some work on it. First of all, I've got a 3 there. If I factor the 9 out of the square root, it comes out as a 3. 3 times 3 is equal to 9. So I'm going to put a 9 out in front. And then what am I left with? I'm left with 1 minus sine squared. 1 minus sine squared is cosine squared. The square root of cosine squared is cosine. So this whole thing becomes a cosine. Here's a cosine, so I end up with a cosine squared. Okay, all from 0 to pi over 2. See that? How do we do this one? Well, remember, this is one of those harder ones where you have an even power, so you have to use a trig substitution. And the trig substitution is, it's 1 plus the cosine of 2u divided by 2 du. Okay, I haven't integrated it. All I did was just made a trig substitution. This is equal to this. Now I can continue from there. So I'm going to get, first of all, I'm going to get 9 times, let's just break it up, times 1/2 du plus 9 times, let's bring the 1/2 out front of both of these, might as well. 9/2, here's a 1, 9/2, and I'm going to get a cosine of 2u du, both of these from 0 to pi over 2. Okay? Well, this one's easy. The antiderivative is u, and I evaluate u from here to here. It's just going to be pi over 2. So it's going to be pi over 2 times 9/2. So here's 9/2 times pi over 2 right there. Okay, what about this one? It's going to be 9/2. What's the antiderivative of cosine of 2u? It's the sine of 2u divided by 2. We did that one earlier in the course. I'm not going to repeat it each time. It's going to be that. So there's the antiderivative. Evaluate from 0 to pi over 2. So notice that this is going to be 9 pi over 4. And then here what happens? If you stick in pi over 2 in here, you're going to get 2 times pi over 2. 2 times pi over 2 is pi. The sign of pi is 0. So if you stick in this, you get 0. If you stick in 0, the sign of 0 is also 0. So that gives you all one big fat 0, and you just get 9 pi over 4, okay, as the final answer. Here's my question. Could you have guessed that was the answer? Or I shouldn't say guess. Could you have gained that was the answer? Look at this function right here. This is the function you get by starting with the equation of a circle. See there? There's the equation of a circle with radius 3 right there. And if you solve this for y, you get the square root of 9 minus x squared. That gives you the top half right there. And if you integrate it just from 0 to 3, then you're getting just the first quadrant. So what's the area? What's the area of an entire circle? The area of an entire circle is pi times the radius squared, which is that, and we have 1/4 of a circle, so it's over this. So there's our 9/4 pi right there. So this particular one you could have gotten just by thinking about it geometrically. You could have gotten the answer. Okay, so those 3 problems, there are lots of them you can do, but those 3 kind of show you everything there is to do in this section. And so you can take it from there and see what other ones you can have fun with. Very good.